Throughout this lesson, we will talk about what is pressure and how we measure the pressure of gases. So first of all, we want to know what is pressure exactly. Pressure is the force applied to a given area, and we represent that by pressure equals force divided by area, which is this equation right here. The units we use are pascals, which are abbreviated as PA, but since pascals are very small, we sometimes use kilopascals, which is 1,000 pascals. So what does a force applied to an area have to do with gases? Well, let's find out. Well, gases exert pressure on objects they come in contact with. So for example, when you blow up a balloon, the air pushes against the elastic sides to keep it firm. So then gas pressure is caused by the simultaneous collisions of gas molecules against an object they come in contact with. Another gas pressure we are exposed to every day is atmospheric pressure, which is when molecules of the atmosphere collide with objects. In order to measure atmospheric pressure, we use a device called the barometer. A barometer is a container of some sort filled with liquid. The container is represented down here, and the gray is the liquid. The liquid is usually mercury. So the tube contains a vacuum. This is what the vacuum looks like. It's this empty space right up there, a vacuum. So a vacuum is a space containing no matter. There is zero pressure in a vacuum due to the absence of particles in the vacuum. So if pressure exerted down on the mercury, the arrows will be my pressure. It will then suck up the mercury into this tube until it hits a certain point, which on this barometer is this point right here. This is caused because on the side of the tube there is air. So that is my air right there on the side of the tube, and which exerts atmospheric pressure. So say we're at sea level. This is our sea level, and pressure is coming down on us, which drives the mercury back up the tube to hit this certain height. So this certain height is 760. So it's 760 millimeters of mercury, which is shown right here. So 760 millimeters of mercury is what we use to measure atmospheric pressure. So say if we are at a higher altitude, such as Mount Everest, it will then be at a much lower height of mercury because of the less atmospheric pressure. So the distance of mercury has risen to the 760 millimeters of mercury, which is our standard pressure. So remember that 760 760 millimeters of mercury is standard pressure, and so I am actually going to use SP to represent standard pressure. And so there are many other units represented by standard pressure, so I'm going to go over those real fast. One is 760 of torr, which seems to be most common. Whoops. All right, the next one is 1 ATM. And so ATM is one you're going to want to remember. Remember ATM. It is atmospheric pressure. ATM, atmospheric pressure. And so our last one, it is going to show up a lot, so that's why I mentioned memorize ATM. So our last one is a metric unit, which is going to be 101.3 kPa. And so we're coming back to that kPa, which once again is kilopascals, which we will see often because it is our metric unit. Alrighty, so this is it on the barometer. And so I'm going to explain another device that we use to measure the pressure of gas in a confined container. Alright, so our next device is called a manometer, and it measures pressure of gas in this closed container. It does that by comparing it to the atmospheric pressure. So a manometer is a U-shaped, exactly what I just pointed to, tube, and I can like attach something to either end, leaving one end open, which can determine our atmospheric pressure. So I'm going to do an example right here on this manometer. So ignore this piece right here. This isn't an actual manometer, but since they are U-shaped, I wanted to use this example so I could be able to write on it and show you guys exactly how it works. This is more of what they look like, right? This diagram right here. So anyway, I'm going to use this one to show you my example of how a manometer works. Alright, so I'm going to fill the manometer of mercury to a certain level. So I'm just going to... Okay, so all of this is going to be my mercury right in there. And the tops are going to be 1 millimeter of mercury. Hg. Which millimeter of Hg ATM, which is, so it's actually not going to be the Hg, it's going to be ATM, which is, once again, atmospheric pressure. Remember, ATM is showing up again, atmospheric pressure. And so, remember the atmospheric pressure is 760 millimeters of mercury. Remember that, ATM, 760 millimeters of mercury. So anyway, I am going to, so I filled up the barometer, and so I'm actually going to leave this side open also for the same 1 millimeter of ATM. So I'm just going to draw an arrow because I don't want to write it again. So both sides are going to be open right now. So if the pressure at both ends is equal, you will see that the level of mercury on both sides is equal of the U shape. So look at, so if pressure is coming down from both sides and they're both 1 millimeter of the atmospheric pressure, they are both pushing down the same amount, which will lead the mercury to be equal on either side of the U shape, leaving the mercury to sit equally. So there are two other cases I'm going to show you, lower pressure and higher pressure. And so I will draw the lower pressure one up here. Okay, well, yeah. Okay, so so this is the lower, and I'm going to use P for pressure. So lower pressure. All right. And on the lower pressure, mercury will be higher on one end than the other. So lower pressure, it's going to be higher on this end than, say, this end. And so the ATM, atmospheric pressure, is pushing down on this end, bringing it, so this is going to be, once again, the 1 millimeter of ATM. This is the one side I left open, ATM. And so this side is pushing down on this side, bringing the mercury to be fuller upon the lower side. And so the next one is going to be higher pressure. So let me show you higher pressure. Higher. Higher pressure. Once again, I'm going to leave 1 atm once again on this side. Millimeters of atm. And so for the higher pressure, we will see that the side with the higher pressure will be lower than the level of mercury of the atmospheric pressure, ATM. So for this one, it's going to be higher on the higher side and lower on the atmospheric pressure side, as you can see. So on this side, it is pushing down on, so for this one, it's going to be higher on the, so the higher pressure is going to be lower than the 1 atomic pressure. So the atomic pressure is going to be higher because on the higher end, it is going to be pushing down, leading the mercury to go up higher on the 1 atomic pressure. All right, so that's it for the low and the high. And the next, we are actually going to measure the pressure of gas. How can a manometer measure the pressure of gas? It is the question that we use to figure out some equations. So I'm using these same pictures right here. Don't worry about the tops of those at all. Just please think of these as a manometer. So for this one right here, this one, okay. All right, so this one right here, we're going to have, let's just make up a pressure. So this one's going to go right there, and it's going to be higher on this end. And so here is our mercury flowing through. So this is going to be our lower pressure. So we're going to have a lower on this side, which is the 1 millimeters of ATM coming in. It's going to be higher on the lower side. Remember that it is higher on the lower side for the lower pressure, and it is higher on the ATM side for the higher pressure. So for this one, let's say this whole, so we're going to find the distance. So here is the distance of this one, and here is the distance of this one. I simply just bring over the lines of what they are to measure the distance. And so this is going to be how we find the distance of both of these. So say the distance of this entire thing is 30. And remember the ATM is 760 millimeters of mercury. So simply what we do for the lower pressure, I'm going to write lower so you guys remember which one we are working on. Lower pressure. All right, so simply when you're working with lower pressure, finding the distance, what we do is we take the atmospheric pressure, which is the 760, and we simply subtract it by however much this total distance is between these two. So we simply do 760 minus 30, which gives us a total of 730 millimeters. Oops. Millimeters of mercury. So that means the lower pressure system is 30 millimeters of the mercury. So then it's less than 760 millimeters of the mercury. So then the final answer is 730 millimeters of mercury, and that is a G. Alrighty, so then this one I'm going to use for the high pressure. High pressure, remember ignore these tops. And so this is going to be the high side right here. This is going to be the 1 ATM. ATM. Atmospheric pressure. Remember ATM is atmospheric pressure. All right, so for the high pressure system, we are going to have an imbalance right here. So I'm going to show you, we'll have this side is going to be lower than this side because the higher pressure side is pushing down, pulling it up to the atmospheric pressure. And so this all in between is once again the mercury. And so in order to measure the pressure of gas with the higher pressure system is going to be simply to do the same exact concept is bringing these two over, finding the distance of these two. So for this example, remember once again, this is 760 millimeters of mercury, which is our atmospheric pressure. Remember that. Always remember 760, atmospheric pressure, ATM. And so we are going to find the difference of the millimeters. So this means that the pressure of the high pressure is so that the millimeters higher than the standard pressure is going to be 50 millimeters higher than the standard pressure. So this is going to be 50 right here. And so since 760 is the standard pressure coming in, this means that the high pressure area will be 810. So 760, once again I'm going to repeat that, is the standard pressure. And then this means that the high pressure is coming in at 50. So we are going to add 50 to the high pressure, essentially making it rise to 810 millimeters of mercury. Alright, so that is all on gas pressure and how to use the barometer and the barometer to find out the atmospheric pressure. So thank you guys.